Good morning. This is P. Anand Reddy. Today we are going to discuss basic engineering mathematics. The topic is matrices. In this subtopic is the inverse of a matrix. Now, after completion of this period, you would able to find the inverse of a matrix and definition of a inverse of a matrix. After completion of this period, you would able to define the inverse of a matrix, existence of inverse of a matrix, and finding the inverse of a matrix. Now, once you recap, what is the adjoint of a matrix, 2 by 2 matrix A, B, C, D? See here, adjoint means the transpose of cofactor matrix. So here, with the help of the transpose of cofactor matrix, the element of cofactor of A is D and B is C, B is minus C is minus B, and D is A. So by interchanging that, you can get D minus B minus C A is the adjoint of this 2 by 2 matrix. Now, what is the inverse of this 2 by 2 matrix A, B, C, D? See, inverse is 1 by AD minus 1 by AD minus BC, that is 1 by determinant of adjoint of AD minus B minus C minus A. So that is 1 by AD minus BC, D minus B minus C A. Now, inverse of a matrix. For a square matrix capital A is a square matrix. If there exists a matrix capital B such that AB is equal to BA is equal to I, then B is said to be inverse of A and it is denoted by A inverse. That is B equal to A inverse. Now, if B is the inverse of A, then A is also called the inverse of B, vice versa. Now, only a square matrix possesses inverse matrices. The inverse of a square matrix, if it exists, it is unit. Inverse of a matrix, unit matrix is itself. The properties of inverse. Number one, if AB whole inverse is B inverse into A inverse, this is the reversal property. A inverse whole inverse is A itself. Third one is A into A inverse equal to A inverse into A equal to identity. These are the property. No, sorry. Fourth one is A transpose whole inverse is A inverse whole transpose. K into K A whole transpose is whole inverse is 1 by K into A inverse. Determinant of A inverse is 1 by delta. A formula to find the A inverse. If A is a non-singular matrix, otherwise we could not find the A inverse. So if A is a non-singular matrix, then adjoint of A into adjoint A is equal to adjoint of A into A is equal to determinant of A into I. Therefore, A inverse is equal to adjoint A by delta. Adjoint A by delta. In place of A into adjoint A by delta is equal to adjoint A by delta into A is equal to identity. So, A into adjoint A by delta is identity. So that A is adjoint A by delta is the inverse of A, that is A inverse equal to adjoint A by delta. Here determinant of A is the denominator position, so A must be a non-singular matrix, otherwise denominator 0 is undefined. The inverse exists if for a non-singular matrices only. The inverse does not exist for a singular matrix, that is if determinant of A is 0. Find the inverse of the matrix. A is equal to 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. The solution is, first, for the existence of inverse matrix, it should be a non-singular. So first we'll verify is it singular or non-singular by evaluating determinant of A. Here determinant of A is determinant of 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. So expanding with the help of first row, 1 into AD minus BC, 3 minus 0, minus 2 into AD minus BC, minus 1 minus 0, minus 2 into AD minus BC, 2 minus 0. With the help of this, 1 into 3 minus 0, minus 2 into minus 1 minus 0, minus 2 into 2 minus 0, that equal to 3 plus 2 minus 4, that is 1. 1 is not equal to 0. Therefore, A is a non-singular matrix. Therefore, A inverse is exist. Now for the A inverse, the formula is adjoint A by det A. For evaluation of adjoint A, we need to find cofactor matrix. So that cofactor matrix is the matrix obtained by replacing the elements by their corresponding cofactors. The cofactor of 1 is the determinant of the matrix by eliminating the first and first column, that is 3 0 minus 2 1. Its determinant is 3 minus 0. Here the signs are plus minus alternative for the cofactor signs. Next element is minus. After deleting first and second column, minus 1 minus 0. The third element is after deleting first and third column, this is actually plus. AD minus BC, minus 1 minus 2, that is plus 2 minus 0. The second row elements are minus AD minus BC, 2 plus 2 minus 4. Next element is plus AD minus BC, that is 1 minus 0. A third element of the second row, that is by deleting second and third column, minus 2 minus 0. The last row elements that are the cofactor of 0 is plus 0 minus of minus 6, that is 0 plus 6. Next element is minus of 0 minus 2, that is 0 minus 2. The last element after deleting third and third column, 3 plus 2. Now these are the cofactor elements. After simplifying these cofactor elements, you can get it as cofactor matrix A is equal cofactor matrix of A is equal to 3 1 2 2 1 2 6 2 5, that is B. Therefore, after getting B, we need to find the first adjoint of A. Adjoint of A is B transpose, cofactor matrix transpose, that equal to 3 2 6 1 1 2 2 2 5. Therefore, adjoint of A is equal to A inverse equal to adjoint A by det A, that is 1 by 1 into 3 2 6 1 1 2 2 2 5. Therefore, the inverse is 3 2 6 1 1 2 2 2 5. This is the required inverse of the given matrix A. So here I repeat once again the main process to find the inverse of a matrix. First, you have to check, is it singular or non-singular? If it is non-singular, then find the cofactor matrix. Then with the help of cofactor matrix, to find the adjoint matrix, that is a transpose of cofactor matrix. After getting the adjoint, by the definition of the inverse, A inverse equal to adjoint A by det A. So with the help of that formula, you can get the inverse of a square matrix. Now the next problem. If A is equal to 1 by 3, 1 2 2, 2 1 minus 2 minus 2 1 minus 1, then show that A inverse is equal to A transpose. For this problem, given that A is equal to 1 by 3, 1 2 2, 2 1 minus 2, and given that A is equal to 1 by 3, 1 2 2, 1 minus 2, minus 2, 2 minus 1. Now, for this matrix, first we will find the determinant of this matrix. Determinant of A, we have to show A inverse equal to A transpose. So, this problem you can get without finding A inverse also you can get. by getting A transpose. Uh, and with the help of A transpose, it's enough to show that A into A transpose equal to identity, that is A transpose into A. So here A transpose is 1 by 3 into the rows and columns are interchanged. After multiplication, 1 by 3 into 1 by 3, 1 by 9. 1 into 1 square, determine product of the matrix 1 2 2 2 1 minus 2 minus 1 minus 2 2 minus 1 into 1 2 minus 2 2 1 2 2 minus 2 minus 1. After multiplication of this, you can get 1 by 9 into 1 by 9 into same products, that equal to 1 by 9 into first row of the first matrix, first column of the second matrix, the sum of the sum of the products of corresponding elements, 1 into 1 plus 2 into 2 4 plus 2 into 2 4, that next 2 plus 2 minus 4 minus 2 plus 2, 4 minus 2. Next second row, 2 in 2 plus 2 plus minus 4 4 plus 1 plus 4, minus 2 minus 4 plus 2 plus 2 minus 2 plus 4 minus 2 minus 4 plus 2 plus 2 4 4 plus 1. So this is 900,090,009 into 1 by 9. After multiplying with 1 by 9, you can get 100,010,001. So that is I equal to, that is I. Therefore A into A transpose equal to I. Similarly, we can prove A transpose into A equal to identity. Therefore A transpose equal to A inverse by the definition of inverse matrix. Now next problem. Find the inverse of the matrix 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4. Let A is equal to 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4. Now for getting the inverse, we have to find we have to find determinant of A, because we have to verify is it singular or non-singular matrix. For that, determinant of the matrix A is determinant of 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4, that equal to 1 into minus 12 minus 12. Sorry, here the bracket is missing. 1 into minus 12 minus 12 minus 1 into minus 4 minus 6 plus 3 into minus 4 plus 6. Here the typical mistake, that will get it as minus 8, which is non-zero. Therefore A is a non-singular matrix. Therefore we can find its inverse. A inverse is exist. Now for this evaluation of A inverse, we need cofactor for matrix. Cofactor matrix of A is equal to, here the small mistake, minus 12 minus 12 minus of minus 4 minus 6 minus 4 plus 6 minus of minus 4 plus 12 plus of minus 4 plus 6 minus of minus 4 minus plus 12 minus 3 minus 9 minus of minus 3 minus 6 3 minus 1. Now after simplifying, you can get cofactor matrices minus 24 minus 10 2 minus 8 2 2 minus 12 6 2, that is B, we can say as B. Now the adjoint of A is B transpose, that is cofactor matrix transpose. We can get that as minus 24 minus 8 minus 12 10 2 6 2 2 2. Now we have to, hence the inverse of a given matrix A is A inverse equal to adjoint A by det A. Here det A is minus 8, adjoint A is the above matrix. Therefore 1 by minus 8 into minus 24 minus 8 minus 12 10 to 6 2 to 2. So after simplification of this, you can get it as 3 1 3 by 2 minus 4 by 5 minus 5 by 4 minus 1 by 4 minus 3 by 4. Next minus 1 by 4 minus 1 by 4 minus 1 by 4. This is the required inverse of the given matrix. Next find the inverse of the matrix A is equal to 2 1 0 minus 1, 3, minus 2, minus 3, 0, 4. Let A is equal to, given matrix is A equal to 2, 1, 0, minus 1, 3, minus 2, minus 3, 0, 4. Now we have to find the determinant of A. The determinant of A is 2 into 12 minus 0 minus 1 into determinant of that matrix after deleting first and second column. So minus 1 into minus 2 minus 4 plus 6 plus 0 into minus 1 minus 3 0 3 3 0, that is 2 into 12 minus 1 into minus 4 minus 6 plus 0 into 0 plus 9, that will get it as 34, which is non-zero. Therefore A is a non-singular matrix, therefore A inverse is exist. Now we have to find a cofactor matrix of A, that equal to 12 minus 0 minus of minus 4 minus 6 0 plus 9 minus of 4 minus 0 8 minus 0 minus of 0 plus 3 minus 2 minus 0 minus of minus 4 minus 0 6 plus 1. After simplification of this, you can get 12 10 9 minus 4 8 minus 3 minus 2 9 4 7. This is a cofactor matrix. We can say it as the adjoint of A is this as a transpose, that is 12 minus 4 minus 2 10 8 4 9 minus 3 7. Therefore adjoint A inverse equal to adjoint A by dt, that is 1 by 34 into 12 minus 4 minus 2 10 8 4 9 minus 3 7. This is the inverse of the uh, given matrix. Now this next problem, find the inverse of the matrix. A is equal to minus 4 minus 3 minus 3 1 0 1 4 4 3. Let us take given that A is equal to minus 4 minus 3 minus 3 1 0 1 4 4 3. Now we have to find the inverse of the determinant of this matrix. Determinant of A is equal to minus 4 into 0 minus 4 plus 3 into uh, 3 minus 2 4 minus 3 into 4 minus 0. So this is 16 minus 3 minus 12, that will get it as 1. Therefore A is a non-singular matrix, therefore A inverse is exist. Now the next one is to find the cofactor matrix of this matrix. Cofactors are 0 minus 4 minus of 3 minus 4 4 minus 0 minus of minus 9 plus 12 minus 12 plus 12 minus of minus 16 plus 12 minus 3 minus 0 minus of minus 3 minus 4 plus 3 0 plus 3. Now the cofactor matrix is minus 4 1 4 minus 3 0 4 minus 3 1 3, that equal to adjoint is cofactor transpose, that equal to minus 4 1 4 minus 3 0 4 minus 3 1 3 whole transpose, that will get it as minus 4 minus 3 minus 3 1 0 1 4 4 3. Therefore A inverse is adjoint A by det A, that is 1 by 1 minus 4 minus 3 minus 3 1 0 1 4 4 3, that is minus 4 minus 3 minus 3 1 0 1 4 4 3. If you observe this problem, the given problem is minus 3 minus 4 minus 3 minus 4 minus 3 minus 3 1 0 1 4 4 3. This matrix is the self adjoint and self inverse. So rarely some of the problems having the self inverse and self adjoint. This is the one of that problem. In basically inverse identity matrix is the self adjoint and self inverse, but this one is also one of the rare problem which having this self inverse and self adjoint also. Now the next problem, if A is equal to 1 2 3 1, then prove that A square minus 2A a square minus 2A minus 5I equal to 0, and also find A inverse. With the help of this you can find the A inverse. Given that A is equal to given that A is equal to 1 2 3 1, So for the proving a square minus 2a minus 5a equal to 0, we need a square. A square is a into a, that is 1 2 3 1 into 1 2 3 1, that is 1 into 1 plus 2 into 3, 1 into 2 plus 2 into 1, 3 into 1 plus 1 into 3, 3 into 2 plus 1 into 2. After simplifying this, you can get it as 7467. This is a square. Now minus 2a. 2a is 2 times of a, that is 1 2 3 4 1. So 2 into 1 2 4 6 2. This is 2a. And 5i is equal to, I is where I is unit matrix of second order 1001, that is after multiplying with 5 5005. Now we have to simplify that. A square minus 2a minus 5i equal to, that is 7467 minus 2462 minus 5005, that is 7 minus 2 minus 5, 4 minus 4, 4 minus 4 minus 0, 6 minus 0 minus 6 minus 6 minus 0, 7 minus 2 minus 5. So this is 0 0 0 0. This is 0 matrix, null matrix. Therefore this is the hence the result is proved. But with the help of this result, we have to find A inverse. From this 5i is equal to 2a minus a square. So from this, pre-multiplying with both sides of pre-multiplying with a inverse on both sides, we get 5i into a inverse, 2a into a inverse minus a square into a inverse. From this 5a inverse equal to 2i minus a into a into a inverse. A into a inverse is identity, so minus 2a 2i minus a. So for that you can write it as 5a inverse equal to 2i minus a, that is 2 times of 1001 minus a is 1231. So this is 2002 minus 1231. 1 minus 2 minus 3 1. This is 5a inverse. A inverse equal to 1 by 5 of, so that is 1 by 5 of 1 by 5 of 1 minus 2 minus 3 1. This is the inverse of the given matrix. Now here, once you recall, we have discussed about the definition of A inverse of A, and existence of A inverse, and the finding the A inverse. Now some quiz problems. If A is a square matrix, then A into A inverse equal to A inverse into A equal to, this is identity by the definition of A inverse. So first option A, second option 0, third option I, fourth option none of these. So third option is correct option, I is the correct one. Now second problem is, the inverse of the matrix A is exists if A is non-singular matrix, that is determinant of A is non-zero. So the first option is A is non-singular matrix, so this is the correct option. A is a singular matrix, this is the wrong option. A is a null matrix, this is the wrong option. None of these, the first one is the correct option. If A is a non-singular matrix, then A inverse equal to adjoint A by det A. This is the correct option. A is the correct option. B is the adjoint A by det A. A is the determinant of A by adjoint A. B is the adjoint A by det A. C is the adjoint A into det A. D is none of this. B is the correct option. Adjoint A by det A. Here the previous exam questions, that is if A is equal to 1 2 minus 2 minus 1 3 0 0 minus 2 1, then find A inverse. A inverse is as usual, you can check the singularity of this matrix A, that is determinant of A. If it is non-zero, then A is non-singular, then you can find its inverse by cofactor matrix transpose by determinant of A, that is adjoint A by det A. Same, find the inverse of the matrix. 1 minus 2 3 2 minus 1 minus 4 minus 3 2 1. Some of the assignment problems. Find the matrix, inverse matrix of A 0 8 2 3 9 5 6 0 6. Next, if A is equal to minus 1 2 4 1 1 3 3 2 3. Find A inverse and verify A into A inverse equal to A inverse into A is equal to identity. For this problem, actually, first we have to find the A inverse, but with the help of determinant of A is non-zero, and with the help of cofactor matrix, with the help of that adjoint matrix. After getting adjoint matrix, A inverse is adjoint A by det A. So with the help of that, you can find A inverse. After finding A inverse, we can multiply with A into A inverse and post multiply with A inverse into A, and that both results will get identity. Then we have to prove that the statement. Now third one, if A is equal to 1 2 2 2 1 2 2 2 1, then show that A square minus A 4A minus 5I equal to 0. Hence determine A inverse. So this is one of the we have discussed one of the problem with a 2 by 2 matrix, but it's a 3 by 3 matrix. So here first we'll find A square. That A square you can get it as 9 8 8 8 9 8 8 8 9. After getting A square, 4A. 4A means 4 times of this one, 4 8 8 4 8 4 8 8 8 4, and then find 5I. I is the 3 by 3 unit matrix. 5 0 0 0 0 0 5 0 0 0 5. After simplification, all this you can get it as a 0 null matrix. Now after getting this, from this result you can get it as you can get it as you can get it as 5I is equal to 4A minus A square minus 4A. So A square, already we have A square, that is 9 8 8 8 9 8 8 8 9 minus 4A. A square minus 4A, 4 times of this 4 5 8 8 8 4 8 8 8 4. Now 5I is equal to A square minus 4A. You can get it as 5 0 0 0 5 0 0 0 5. Sorry, here with after getting 5I is equal to A square minus 4A. So pre-multiply with A inverse. 5A inverse equal to A minus 4I. A minus 4I means 5A inverse equal to A minus 4I 4 0 0 0 4 0 0 0 4. So you can get it as minus 3 2 2 2 minus 3 2 2 2 minus 3. This is 4A inverse 5A inverse equal to A inverse equal to 1 by 5 into minus 3 2 2 2 minus 3 2 2 2 minus 3. This is the A inverse 1 by 5 of that matrix. Now here, up to here, what we have discussed, just once you recall. Just once we recall what we have learned today. The main slides I'll show once again. Now also observe the inverse of a matrix. The definition of inverse of a matrix. If A is a square matrix, then there exists a matrix B, square matrix B, such that AB into AB is equal to BA is equal to identity. Then B is called the inverse of A. It is denoted by A inverse. That is A inverse equal to B. Is A is a square matrix if there exists a matrix B such that AB into AB is equal to BA is equal to identity. Then B is called the inverse of A. It is denoted by A inverse. If B is the inverse of A, then A is also called inverse of B. Uh, Only square matrix possess the inverse. Not only square matrix, only non-singular square matrices possess the inverse. Inverse of a square matrix, if it is exists, that is unique. Inverse of unit matrix is itself. Now some more properties. That properties are AB whole inverse is B inverse into A inverse. A inverse whole inverse is A itself. Inverse of A is inverse. A into A inverse equal to A into A inverse into A equal to identity. This is the definition of the inverse matrix. A transpose whole inverse is A inverse whole transpose. It means before transformation or after transformation, it will remain the same. K a whole inverse is 1 by K into A inverse. Determinant of A inverse is 1 by determinant of A. Formula to find the A inverse. A inverse is, if A is a non-singular matrix, then A into adjoint A is equal to adjoint A into A equal to determinant of A into identity. With the help of this result, we can get the formula, that is A into, if you can write this is determinant of A is left hand side, then you can get A into determinant of adjoint A by det A is equal to adjoint A by det A into A is equal to identity. So with the help of that, you can get it as A inverse equal to adjoint A by det A by the definition of A inverse. Now inverse of the inverse exists for non-singular matrices only. The inverse does not exist for a singular matrix. That's since the determinant of A is 0, because with the help of formula, that formula is adjoint determinant A inverse is adjoint A by det A. So here det A is the position of denominator. If the denominator is 0, that function is does not exist, undefined for that. So the determinant of A should be a non-zero. That means A should be a non-singular matrix. Otherwise, A inverse does not exist. So some of the problems we have seen just now for getting the inverse of A. A is equal to 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. For getting the A inverse, we have to find the determinant of A. Then check is it singular or non-singular. With the help of that, you can find the A inverse. After getting the determinant of A, the determinant of A is 1, which is non-zero. Then therefore A is non-singular matrix. Therefore A inverse is exists. Now find the cofactor matrix. After getting the cofactor matrix, you can find adjoint of A. That adjoint of A is transpose of cofactor matrix. Here we got the cofactor matrix 3, 2, 3, 1, 2, 2, 1, 2, 6, 2, 5. Therefore adjoint of A is, it's a transpose, that is 3, 2, 6, 1, 1, 2, 2, 2, 5. Then A inverse is adjoint A by det A, that is 1 by 1, det A is 1, 3, 2, 6, 1, 1, 2, 2, 2, 5. Therefore that matrix is 3, 2, 6, 1, 1, 2, 2, 2, 5. This is the inverse of the matrix. Similarly, we can take some more problem. This is one of the different way to get the result. Actually, A is 1 by 3, 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 3. Then show that A inverse equal to A transpose. Here, for getting these two ways are there as well. You can find the transpose of A inverse by getting the determinant of A and adjoint cofactor adjoint and A inverse. That is maybe coincide with the A transpose. So here another way is there. while taking A transpose and multiply with A into A transpose. If you check that, that is a very simple method. So let us take A equal to the given matrix A transpose. We have to show that A inverse equal to A transpose. It's enough to show that A into A transpose equal to identity, that is A transpose into A. So first we'll find A into A transpose, that is 1 by 9 into that matrix. After multiplication of this, you can get it as 900090009. So that will get identity. Therefore, A into A transpose equal to A inverse. Similarly, we can prove A transpose into A equal to identity. So A transpose equal to A inverse. Next, one more problem, that is A equal to 1 1 3 1 3 minus 3 minus 2 minus 4 minus 4. That will get it as given that A is equal, let A equal to this matrix. We have to show that A is a non-singular matrix. So find A determinant of A, that will get it as minus 8. Therefore A is a non-singular matrix. Therefore A inverse is exists. Now we have to find the A inverse. For getting that A inverse, we have to find cofactor matrix of A, where the elements are replaced by their corresponding cofactors. After getting the cofactor matrix as a minus 24 10 2, minus 8 2 2, minus 12 6 2, we can say this as a B, because it's more convenient to find adjoint of A. Adjoint of A is transpose of B. So after transpose of B, you can get minus 24 minus 8 minus 12 10 2 6 2 2 2. Therefore, hence the inverse of the given matrix A is adjoint A by det A. With the help of that, 1 by minus 8 into minus 24 minus 8 minus 12 10 2 6 2 2 2. This is the A inverse. If you are interested, you can simplify, otherwise you can leave it. Next, find the inverse of 2 1 0 minus 1 3 minus 2 minus 3 0 4. First we'll find determinant of A, that will get it as 34, which is non-zero. Therefore A is non-singular matrix. Then we can find its inverse. A inverse is exist. Cofactor matrix, the elements are replaced by the corresponding cofactors. That will get it as 12 10 9 minus 4 8 minus 3 minus 2 4 7. Now adjoint of A is, it's a transpose, cofactor transpose. You can get it as 12 minus 4 minus 2 10 8 4 9 minus 3 7. Now inverse is A inverse is adjoint A by det A, 1 by 34 into adjoint of A, that you can replace as it is. This is the required matrix. Now one more example, that is inverse of A is equal to minus 4 minus 3 minus 3 1 0 1 4 4 3. So first we'll find determinant of A. The determinant of A is 1. Therefore A is non-singular. Therefore A is inverse is exists. Now we'll take adjoint of A. That adjoint of A is cofactor matrix. Matrix is replaced by their corresponding cofactors. Minus 4 1 4, minus 3 0 4, minus 3 1 3. Now adjoint of A is, it's a transpose, that is equal to minus 4 1 4, minus 3 0 4, minus 3 1 3. That's the transpose. Will get it as minus 4 minus 4 minus 3 minus 3 1 0 1 4 4 4 4 3. Therefore A inverse is adjoint A by det A. That will get it as the same matrix, that is here this matrix has having this self inverse, self adjoint. Now the next, if A is equal to 1 2 3 1, then prove that A square minus 2A minus 5I equal to 0. Hence find A inverse. This is one of the method to find the A inverse with the help of the, actually this is characteristic equation. With the help of characteristic equation also we can get this equation. A square minus 2A minus 5I is the characteristic equation of the matrix capital A is equal to 1 2 3 1. So with the help of that you can get the inverse. So that is also one of the way to get the matrix inverse of the given matrix. Now here first we have to show that a square minus 2a minus 5a equal to 0. So first we'll find a square, that a square value is 7467, and minus 2a is there, so 2a, 2 times of a, 2 6 2 4 6 2, and 5 5 into identity matrix 1001, so 5005. So after getting all these values, substitute in the relation, that is a square minus 2a minus 5 left hand side, then you can get it as a square minus 2a minus 5 7467 minus 2462 minus 5005. Therefore after simplification of these you can get 0000. Therefore a square minus 2a minus 5a equal to 0. From this 5a equal to 2a minus a square. Now multiply, post multiply or pre multiply, you can take any one multiplication, multiply with a inverse, you can get a inverse into I in the left hand side, 5a inverse equal to 2i minus a, that will get it as 2i minus a. So after multiplication you can get it as 5a inverse equal to 2i minus a, 2 into 1001 minus a 1231. So for 2002 minus 1231, it will get 1 minus 2 minus 3 1. So after getting this therefore a inverse equal to 1 by 5 of 1 minus 2 minus 3 1, that is the required a inverse. Now in this case already we have discussed this summary of quiz problems, also we have discussed that if A is a square matrix, then A into A inverse equal to A inverse into A equal to, this is identity matrix. So in the options, A is 0, B is A is A, B is 0, C is I, D is none of this, C is the correct option, I is the. Next, in the inverse of a matrix, A is exists if A is a non-singular matrix, that is A is non-singular matrix, determinant of A is non-zero. B option is singular matrix, C option is null matrix, D option is none of the above. So A is the correct option, B and C are the wrong options. If A is a singular matrix, then A inverse is adjoint A by det A. First option is det A by adjoint A, C option is adjoint A into det A, B option is adjoint A by det A, D option is none of these. So B is the correct option. Here, typical mistake. Some of the previous examples, previous examination questions, find A inverse if A is equal to 1 2 minus 2 minus 1 3 0 0 minus 2 1. Next problem is find the inverse of the matrix 1 minus 2 3, 2 minus 1 minus 4 minus 3 2 1. Some of the assignment problems, are find the inverse of A 0 8 2 3 9 5 6 0 6. If A is equal to minus 1 2 4 1 1 3 3 2 3, then find the A inverse and verify that A inverse A into A inverse, that equal to A inverse A equal to identity. So automatically it is satisfied. For getting the A inverse, first we'll check is it singular matrix or non-singular matrix. If it is non-singular matrix, then A inverse is exist. For getting the A inverse, we have to find a cofactor matrix of the given matrix, that our elements are replaced by their corresponding cofactors. After getting the cofactor matrix, we have to find the adjoint matrix by transposing that cofactor matrix. Then A inverse is adjoint A by det A. With the help of that, we can find A inverse. After getting the A inverse, we have to find A into A inverse. Verify A into A inverse, that will get identity, and A inverse A also we have to find, that also will get identity. Now one of the problem, if A is equal to 1 2 2 2 1 2 2 2 1, then show that a square minus 4a minus 5i is equal to 0. Hence find A inverse. For this, first we have to find the determinant a square, sorry, a square. That a square is 988 898 889. After getting a square minus 4a, 4 times of a, that will get 488 848 884. Minus 5 times of identity. Identity means 10001. So after multiplication of 5, you can get 500 050 050. Now replace in the left hand side of this statement a square value minus 4a value minus 5i value. After simplification, you can get it as identity 0 0 null matrix. All elements will get zeros. Now if you want to find A inverse, from that statement you have to find phi I is equal to, after taking this phi I left right hand side, you can get a square minus 4a. So phi I is equal to a square minus 4a. From that relation you have to find A inverse. If you multiply with A inverse, you can get phi A inverse equal to a minus 4i. A is this one, minus 4i is I, you can write minus 4i means 400 040 004. If you subtract this, you can get 5i equal to minus 3 2 2 2 minus 3 2 2 2 minus 3. So I equal to 1 by 5 of minus 3 2 2 2 minus 3 2 2 2 minus 3. That is the required inverse of the given matrix. So you can find that. Now this is the end of this session. Thank you.